Physics, part 75. The numerical value of the specific latent heat vaporization is the quantity of heat energy required to convert the unit mass of the liquid to the vapor without any change in the temperature. The SI unit of the specific latent heat vaporization is the same as that for the fusion, that is joule kilogram. For substance with latent heat vaporization L, the quantity heat energy is required to vaporize mass M liquid is given by delta Q mLV. Delta Q is equal to mLV. When a vapor condenses, becomes liquid, the latent heat of the vaporization is released. Similarly, when a liquid solidifies, the liquid becomes solid and the latent heat of the fusion is released. Some values of the specific latent heat of fusion and vaporizations are given here. Material ice or water, and the specific latent heat fusion is 330 kilojoule. Specific heat of the vaporization is 2260. Another material is ethanol. Its specific latent heat for fusion is 108 kilojoule, and specific latent heat for vaporization is 840 kilojoules. The material copper has the specific latent heat for fusion 205 kilojoules, and the specific latent heat for vaporization is 4840. Sulfur has got the specific latent heat of fusion for 38.1 kilojoules. Experiments to determine the specific heat capacity of specific latent heat of a material often involve the use of the electrical heating. The energy inputs determined from delta Q, which is equal to W, is equal to ELT or an equivalent expression, and then equated to MC delta theta or ML. The use of such an equation neglects by heat loss. Experiments should be designed to minimize this error. Use the information given in table 4.5 to determine the heat energy required to melt 50 grams of sulfur at its normal melting point. This is an example. Heat energy required is M into L, 50 over 1000 into 38.1 into 1000, and the answer is 1900 joule, 1900 joules. Now it's your turn. Where appropriate, use the information given in the table. Calculate the heat energy required to melt 50 grams of ice at 0 degrees Celsius. Evaporate 50 degrees of water. Let me do. Evaporate 50 grams of water at 100 degrees Celsius. Using answers to determine how many times more energy is required to evaporate mass of water than to melt the same mass of ice. Exchanges of heat energy. When a hot object and a cold object come into a contact, heat energy passes from the hot object to the cold one so that the two objects reach the same temperature. The law of the conservation, I beg your pardon. The law of the conservation of energy applies in that the heat energy gained by the cold object is equal to the heat energy lost by the hot object. This does, of course, assume that no energy is lost to the surrounding. This simplification enables the temperature to be calculated. Examples. A mass of 0.3, I'll rather provide the example in the next video. And we've been running through this thermal heat energy. and provide you the example in its full content in my next video.